Hello. Hello everyone, welcome to my channel. So today we are going to do Leetcode daily challenge, sum of sub-array minimums. So let us first read this question, then about constraint, then about the examples, and then finally the coding part for the same. So here, given an array of integers array, find the sum of minimum of b, where b ranges over every contiguous sub-array of array. Since the answer may be large, return the answer modulo 10 raised to power 9 plus 7. So basically, let me explain you first this question. And before that, let us check for the constraints. So here we can see that constraints are up to 10 raised to power 4, right? So as per that, if we do n square for the same, it will go to 10 raised to power 8, right? So we can only go ahead with n log n, such types of solution only, not n square. So now, what this question is saying is that here, it's taking time to come up. What the question is saying is that whatever is input is there. Now the point is that say this array which is given to us 3124. What happened to this? Okay, let me show you another thing. Hmm. So basically, the array which was given there 3, 1, 2, 4, right? So basically, the thing is that out of these, how many subarrays are possible? And in all those subarrays, we are required to check the minimum number and we are required to do sum of all the minimum numbers which are possible in all those subarray. So this is thing which we are required to do. But as per the constraint, we can't calculate all the subarrays and then going ahead with the numbers which are there. So that's why we would be required to go ahead with some other sort of solution so that it can also come under constraint. So for that purpose, say in this, if we select this number 3, then we need to check that which is the smallest number which is there next either to towards the left or towards the right of that particular. So if we see towards the left, there is no number, so 3 itself would be there, and if we check towards its right, then again 3 itself is there, right? So in that context, the 3 itself is that particular sub array. So whatever sum we will be taking, say sum equals to 3, right? And this is the only sub array for time being, means at the 0th index. When we go to the first index, then we have this one, then we will be checking towards its left and towards it right, and how many subarrays are possible, that all we will be keeping there, means 3 comma 1, then 3 comma 1 comma 2, then 3 comma 1 comma 2 comma 4, and then 1 comma 2 comma 4, and then 1 comma 2. So all these subarrays are possible, right? And we can clearly see out of all these, the minimum number which is there, that is 1 only. So here we can see 1, 2, 3, 4, 5, 6. So 6 times 1 is occurring, and that we need to add up to our sum. Now we check for the second index, which is our 2. So here, if we check for the 2, then again we will be checking for 2. Then whatever is left to the 2, if it is smaller, then we won't be able to take, because if it is smaller, then it won't be able to make 2 as the smallest number of that sub array, right? So that's why we won't be going towards the right, because here we got this one. So we will be going towards the towards the left. Now we will be going towards the right. So we got 2 comma 4. So because we here in both of these, 2 is the smallest element, and that's why here we will be going ahead with 2 multiply by 2 is that element and it is occurring 2 times. So that is the thing which we will be adding to our sum. Now comes the part for the 4. So for 4, if we see, so here for the 4, here if we go towards the left, then also all are smaller than 4, and if we go towards right then there is no number, so that's why 4 itself would be there, 4 multiplied by 1. So after that, if we add them up, 3 plus 6 plus 2 2s are 4 plus 4, and then this is 10, and this would be 17. So total answer would be 17, and that is what is being required in that first example which is being given to us. So now comes the part that how we will be implementing this particular solution which we have observed here. Now the point is that here what we are doing is that we are checking the present number which is there, right? We are checking that what is the present number, and we are maintaining that what are the left numbers and what are the right numbers which make that present number as the smallest number. Basically, all the sub arrays we are required to count which are towards the left and towards the right. Here we don't need to basically here we don't need to keep the elements, but we are required to keep the distance. So because of that distance only we will be able to check for all the number of sub arrays which could be possible where that present number is the smallest number. And for that purpose what we can do is we can easily, the way we have done that question in stacks, the next greater element, right? So like that, here is that next smallest element. So basically here also we are required to use stack, and by using stack we can maintain those distances, and we can use the separate left and right vector in which we can store those distances. And because of that we will be able to check, basically after that means the way here means by just, if I could say like in layman manner, I have shown you that how we are calculating the sum, right? So like that only, after coding that, we at the end we are required to get to some conclusion, means get to some formula, that by doing this we will be able to get the final minimum sum. So that is the thing, and this is the thing which we are required to code. Now, as you have got the hint that how to code this particular solution, you can go ahead and code the same. And if you have still doubt, you can then resume the video and I'll show you that how we are required to code this solution. So I have coded the same. Hmm, Now it came. Seriously? Okay, fine. वाह, ये काम ही नहीं कर रहा. Okay. Hmm. So here's my coding part. This is just for my reference I have written. So here in the question it was mentioned that we are required to do modulo. So here only I've taken all those, taking the size, then for doing modulo, and for the left and right vectors which we are maintaining for all the distances which are there. And out of that we will be able to get number of subarrays in which that particular element is the smallest. So now as I told that we will be using a stack. So first we are pushing 0th index in that stack, and left of 0 will be equals to 1, means the element itself is at the distance 1. That is what we will be going ahead with. Now as we have already pushed that for the first element, so we are starting from the 1, and now we with the help of that stack what we are checking, if that stack is not empty, and if our present element is less than the element which is at the top of the stack, then we will be popping out from that particular stack. Here what we are doing is, here we are trying to find the next smallest number which could be possible. So that's why here we are checking that if the present number is small, means basically whatever is there at the top of that stack is the greater than our present number, then we will be eradicating all all those means all those basically distances which we have stored at that stack. Here not only here distance won't be there, here basically in the stack we are storing that index. So we are popping out those index, and after that If a stack becomes empty, that simply means that only till this particular we were able to get our present number as the smallest number, and then we will be adding 1 to that I, means this one is basically including our present number, which simply means total distance if less element not found. That is the point. Else, if that stack have some element, right? So whatever present index is there, from that we will be subtracting whatever is at the top of the stack. So this would be for the left vector which we are maintaining, and then at the end we will be pushing our present index, so that this could be useful for the upcoming numbers. Now, while st dot size means while it is there, is here we are just trying to empty that stack. That is what we are doing, because our left is already filled. So we are popping that out. Now comes the part for our right vector, means in which we are storing the right distances, so that we can figure out what are the number of sub arrays for a particular element where it is the smallest element. Now here we are pushing the n minus 1, the index which is there, and the right of n minus 1 equals to 1, again the same, that distance equals to 1. Now here we are starting from the last second element and going till I greater than equal to 0, is including the 0th element. And now here doing the same thing, that if that stack is not empty and if our present element is less than or even equals to that particular element whose index is being stored at the stack. Now here why we have included this equal to sign is, see here, the thing which I was means in this is my cursor, yeah, cursor is visible. So the thing in this, when we were having this 3 1 2 and again we were having 3 was there, right? 1 2 4, these two are also making one sub array, right? And this 1 2 4 and 1 2 is also making one sub array. So just to include this 3, we are making that equals to there, means the thing is that either in left side or in the right side, either of side we are required to include the elements which are on both left and right side. So that's why now I'm taking that towards the right side. So that's why here I have taken this equals to sign. So at that particular time it will just pop out for the fact when this particular is the smallest than the other which are greater. And now because of that, we'll, if the stack becomes empty, then at that point of time we will be subtracting from n, because now here n would be greater. We will be subtracting I from the n. Else what we will be doing, whatever is at the top of whatever is at the top of the stack, because it is from the rightmost side, right? So their index would be surely bigger. So that's why from that we are subtracting our present index, and then at the end we are pushing that index towards stack. So this is how it would be for the right vector which we are storing. Now after both of these things, we will be able to get whatever are there in our left and right. So for that purpose, now comes the part, the last thing which we were doing here, means this thing which we were doing here. Now we are required to basically get into our code. So for that purpose, here I've written that total number of sub arrays are simply by left of I into right of I. Okay, and total contribution in a of I element in final answer would be, means whatever was left of I and right of I multiply by a of I. So that is how our result would be when we will be calculating from I equal to 0 till n. Then a product would be left of I into right of I, and then first we are doing modulo because the number could be bigger, so that's why we are side by side doing modulo. And then that product we will be multiplying with the present element, and again we will be doing modulo, and then at the end we will be just adding up that product to our result, and again we will be doing the modulo, and then at the end for the result also we will be doing the modulo. So by this we will be able to code this particular question. I hope it was completely clear for you all. If you still have any doubt, you could comment that down. Now comes the part for the time complexity and the space complexity for the same. So here we can see that it is n, and now here we can clearly see that here we are popping out, right? So that's why this is like at means there won't be much possibility that it will be going till n. So that's why it won't reach n square solution. But the point is it can even reach. So basically here we feel like it is n square, but the point is that here it is having means each element which is there, it goes only n times into the stack, and here it is already popped out, so stack won't be doing means here stack is the while loop which is being used here, right? So here only means basically only at max n times the elements could be sent, which is because of this for loop, and because of this while loop it is already just popping out, means whatever elements which could be there. So that's why the time complexity which overall becomes that is n, and the space complexity it is all because of the stack and the vectors which we are using here. So this was all for this particular question. If you have any doubt, you would comment that down. And if you really like the explanation, you can like, subscribe, and share this video among your friends. So this was all. Thank you.